This is day 7, due now. Let's review some of the objectives you learned in Unit 1, like combining like terms in an expression, combining like terms in an equation, isolating a variable from its coefficient, solving two-step equations, and then we'll be getting into our next lesson where we'll define what it means to simplify and be able to apply our distributive property and undo complex fractions. On page 1 of your notes at the top it says combine like terms and expressions. Let's review what this means. When you're given an expression, you need to identify your variable terms and your constant terms and combine only like terms together. We have 3 examples here. Let's see if you can go ahead and do all 3 examples, combine your like terms, and write your final answer in standard form as well. Okay, let's see how you did. So in example 1, did you identify the negative 3k as a variable term and the positive k as a variable term? Don't forget to include those signs that come before the terms. And that 1 is a constant. So we're using our circles and squares to be training wheels for our eyes to recognize the terms that we can combine together. The first thing you will combine are your variable terms before your constants. So we have a negative 3k and a, well, what's the coefficient of that other k? 1. Okay, so we have negative 3 and a positive 1. Remember, when you combine like terms, you use the integer rule of SOB. So we have a negative 3 and a positive 1. Those are opposite signs, so we have to subtract. 3 minus 1 is 2, but the bigger sign wins. So negative 2k. Then we combine our constant terms. Well, we only have one constant there, so it's 1. But what do we need to remember to do here? Don't just write 1. What do you need? You need to have the sign in between. Because our constant is coming after our variable term, we have to have a sign no matter what, even if it's positive. So that's your final answer, negative 2k plus 1. Go ahead and try your next example. X is a variable term. Positive 6 is a constant. Positive 6 is a constant. And negative x is a variable term. Alright, we first start by combining your variable terms. We have a x and a negative x. What do we know if something's the same but has opposite signs? What do we call that? A zero pair. So they cancel out. If you have the exact same number or the exact same variables with opposite signs, then they will always create a zero pair. But notice you have a positive 6 and a positive 6. Yes, they're the same numbers, but they're not the opposite sign. So that is not a zero pair. They do not cancel out. Positive 6 and positive 6, those are the same sign, so we have to add. And the bigger sign wins. So when we combine our like terms in this expression, we just get the number 12 as our answer. As we simplify our last expression, and I am again enforcing that the word simplify means to combine your like terms. Let's see. We need to identify our variable terms. Just because it has a y, it's okay. You have a negative 9 and a positive 2. Those are opposite signs, so you have to subtract. 9 take away 2 is 7. Y, but our bigger sign wins. Don't forget that part. So it's a negative 7y. And then we combine our constants. Positive 4. How'd you do? Alright, now you just combined like terms in an expression. Now we need to combine like terms in an equation. Remember the differences? There's an equal sign. And if there's an equal sign, in order to combine a like term on the other side of an equation of that equal sign, remember that you have to change the sign. So let's identify our variable terms in this one. So we have an x, and we have a constant of a positive 4 and a constant of a 7. So our like terms in this equation are the 4 and the 7. But to get it to the other side, we have to change the sign. Make that zero pair so that it doesn't exist on this side. Once you make your zero pair, draw a big fat line and combine. So we bring down the x is equal to, and then we're combining that 7 and negative 4. Those are opposite signs, so you have to subtract. 7 minus 4 is 3, and the bigger sign wins, so it stays positive. So x is equal to 3. Let's look at the next example. First, identify your variable and your constants. Variable terms and constant terms. So we have a negative 2 as a constant, positive y is a variable term, and 10 as a constant. Now I can't write that precise on an iPad, so I should not have circled or included that equal sign. Let me try making my circle one more time for you. That's about the best I can do. So that is a circle around your y variable. So our like terms are the negative 2 and the 10. They're both constants, but we can't combine them until they're on the same side of the equation. So which do I move, the negative 2 or the positive 10? I need to move the negative 2. I want to get it away from the variable. My goal is to get the variable all by itself. So I need to make a zero pair with that negative 2. The zero pair would be a positive 2. And whatever I do to one side, I must do the other. So that's using that inverse operation so that it can cancel out. Now I drew my big fat line and I'm ready to combine. Y is equal to 10 plus 2 combines to 12, and it stays positive. Alright, the last example. Again, identify your constant terms and your variable terms. So 3 is a constant, x is a variable term, and positive 8 is our constant term. So in this example here, what are we trying to combine? The 8 and the 3. But what do I need to move? They're on opposite sides of the equation right now. We need to get them on the same side together. We don't want to move the 3 because that would mean that it would move to the same side as our variable. We need them to be on the opposite side of the variable. So the zero pair I need to create is with the 8. So I make a negative 8 so that I can make that zero pair, but whatever I do to one side of the equation, I must do the other. I draw my big fat line to combine. Cross off my zero pair, so I have x is equal to, and I combine the 3 and the negative 8. Again, those are opposite signs, so you have to subtract. 8 minus 3 is 5, but the bigger sign wins. So negative 5 is equal to x, or, remember you can flip it around, x is equal to negative 5. The other type, or the other step of the types of problems of our one-step problems was isolating a variable from its coefficient. So we had to do this whenever we have a number that's directly beside or under our variable. That's either being multiplied or dividing our variable. So there's, oops, good, it didn't flip on me. So here is your variable term, and here is your constant. So notice in this problem here, we do not have any like terms to combine. We have our variable term on one side and our constant on the other. That's fine, that's what we want. But our goal to solve an equation is still to get your variable all by itself. Right now, what is with your variable? The number that's with our variable is the 2, and it's directly under our variable. So what's our rhyme? Under, up, and multiply. So we have to move that 2 up and multiply it to both sides of the equation. That allows the 2's to cancel out, and we have x is equal to, by the way, notice I did not draw a big fat line to combine. I'm not combining, I'm multiplying or dividing. So remember, with multiplication and division, your integer rules are different. You can remember using the sign triangle. Here we have a positive 5 and a positive 2. Well, 2 positives is always positive, but so 10 times, or 5 times 2 is 10. In the second example, you have 3y is equal to 15. Well, 3y is a variable term. 15 is a constant. So we have no like terms to combine, but we do need to isolate our y from its coefficient of 3. And this time our coefficient is beside our variable. So our rhyme to remember what to do, if it's beside it, you divide it. So we divide both sides by 3. Notice I make a little line underneath the number. Don't go like this all the way across, because that's what you do when you combine. So our little line to show division. It makes it look like a fraction, because that's what a fraction is a division. It's just another way of saying divide. Alright, so if we reduced our fraction, 3 over 3, it equals 1 or cancels out. And 15 over 3 reduces to, so y is equal to 15 over 3 reduces to just 5. All right, last example. 10 is a constant. 5x over 2 is our variable term. Again, nothing to combine, but we do need to isolate our variable from the numbers that are with it. Well, with our variable we have a 5, and we have a 2. Those are the coefficients. So we have 2 coefficients. When you have 2 coefficients beside it or under it, you must take care of the number that's being divided first. So under, up, and multiply, and then beside it divide it. Multiply both sides by 2. So we do this step first. 5x is equal to 20. And then beside it divide it. So we divide both sides by 5. X is equal to 20 divided by 5 is 4. So 4 equals x, or x is equal to 4. So solving two-step equations, the two key concepts, the reason why they call them two-step equations is because you're going to be doing these two steps, combining your like terms and then isolating the variable from its coefficient. And you must do it in that order. So I broke down some steps so far and called it step 1, cross-multiplying complex fractions. We did cover that at the end of unit 1, and I'll give you some more problems of that in a minute. We do not need to do that in this problem because we do not have a complex fraction. So step 1, we're done. Step 2, identify our terms. This will help us to see what we need to combine or isolate. So let's identify our terms. Let's circle our variable terms. There it is. There's one. And put squares around our constants. So now you can see, oh, we've got like terms. And so that's our next step, is we have to combine our like terms before we isolate our variable. So the 4 does not move yet. We have to take care of what number first? Did you say 2? I hope so. That's the number that's on the same side of the variable right now. So we want to get it, combine it with the 6. And how do we combine it? Do you write -2? -2. We had to use a -2 because this 2 up here, even though it doesn't have the sign there, is a +2. When you combine like terms across an equation, you have to change the sign. So we draw our big fat line and combine. That cancels out. That's our 0 pair. So we have p over 4. Just copy the whole problem. I'm going to work left to right every time. P over 4 is equal to, and now I have a 6 and a -2 that I can combine together. Those are opposite signs, so I have to subtract. And the bigger sign went, so it stays 4. So I've combined my like terms, because now I just have a variable term and a constant. It's kind of like all my circles on my left and my squares on the right. That's what your goal is to do when you combine your like terms. Now you need to isolate your variable from its coefficient. So we have a coefficient of 4. That's the 4 that's under our variable right now. How do we get rid of it? If it's under, you move it up and multiply. So we times both sides by 4. That reduces those 4s, cross cancels them. You get p is equal to 4 times 4 is 16. Alright, you try this next one, just as a review. I want you to push pause and work on it, and then push play when you're ready to check. Okay, you ready to go? Alright, do we have any complex fractions here? No, we do not. Remember, complex fraction has more than one term on the numerator or the denominator of the fraction. We're going to get to one here in just a few minutes, but right now let's solve this one. We don't have any complex fractions, so you skip step 1. Step 2, identify your terms. So did you identify that as a constant term, a constant, and a variable term? Alright, step 3, let's combine our like terms together. Let's see, did you write positive 4, and then draw a big fat line to combine? We had to change the sign because we're trying to combine a constant with another constant on the other side of the equation from the variable. So that cancels out. That's that zero pair we were trying to create. And we're ready to combine. I'm going to work my way from left to right. So negative 12 plus 4, those are opposite signs, so I have to subtract. 12 minus 4 is 8, but the bigger sign wins. Don't forget that part. Negative 8 is equal to, and the n over 2 just comes straight down. We can't do anything with it yet. So we finished combining our like terms. Now we need to isolate the variable from its coefficient. The coefficient of n is 2, and it's under our variable, so we have to move it up and multiply. The 2's cancel out. You get n is equal to, that is a 2 times negative 8. What do you have whenever you multiply a positive times a negative? Let's try this. Look at your sine triangle. If we have a positive times a negative, that leaves us a negative. 2 times 8 is 16. So negative 16 is equal to n, or n is equal to negative 16. Now I haven't done the last step there of checking. Again, remember that you can always check your answers. Now, I don't want you to erase your page, but I'm going to erase so you can see me checking here. I'm only going to erase our work here, but I'll leave our answer for a minute. Don't erase it on your page. If you want to do this off to the side, you can. Alright, we're going to check our negative 16 to prove that that is the correct answer. So what you'll do is copy down the original problem, but wherever you see the variable, in this case n, you replace the variable with your solution that you got, the negative 16. Don't forget that 2 underneath it though. That doesn't go away. So we copied the entire problem down, but we replaced our variable with our solution that we're going to check. Now you just need to simplify each side of the equation separately. Well, negative 12, there's nothing to simplify on that side of the equation. It just stays negative 12. We're hoping that the right-hand side of the equation is also equal to negative 12. We have to use our order of operations here because we have no variables. So let's please excuse my dear Aunt Sally. We have negative 4 plus negative 16 divided by 2, or over 2. So we have to do our division first. Negative 4 plus, well, we may not have to write that plus sign there, but here, just a second. We have a negative 16 over a positive 2. A negative divided by a positive is always a negative. 16 divided by 2 is 8. Almost there. Now we can add these two integers together. We have a negative 4 plus a negative 8. So we have to use SOB because it's addition. Those are same signs. -4 and -8 are both the same sign. So you have to add. 4 plus 8 is 12, but the bigger sign wins. The bigger number is 8 and it's negative, so our answer gets a negative. Look, -12 is equal to -12, so your answer checks. Please, please, please take the time on every problem that you do to plug your answer back in and check. And the last thing here we need to review again is what's the difference between our equation on the left with the equation on the right? This is not on your paper, by the way, so just look at the screen right now. You have 2 plus p over 4 equals 6 on the left, and on the right you have n minus 9 over 14 equals -2. Look at the fractions. What do you notice about them? On the left you have a simple fraction, just a variable over top of one number, but on the right in this equation we have a two-term expression above a single term. So if we ever have more than one term on the numerator or the denominator of a fraction, remember what this is called? Complex. And whenever I write the word complex, I would make a big capital X with some arrows on there because that reminds you what you need to do. When you have a complex fraction, you have to cross multiply. So let's practice doing a couple of those. So cross multiply complex fractions. Now this problem should be on your page. Here you have 2 plus v over 11. That is a complex fraction because we have more than one term. And if you want to do your circles and squares real quick just so that you can see that that's the problem here. See, there's a constant variable. Here's a yeah, this is kind of weird. So you can't make a great big circle with it. So when we cross multiply, it means you take the denominator of the complex fraction and you multiply it to the top or to whatever is the numerator on the other side of the equation. If there happened to be a fraction on the right hand side as well, you would also multiply that to the opposite side. That's why we call it cross multiplying the complex fraction. So this problem we only need to do it one direction. We're going to multiply the 11 to the 2. And see how my arrow points up to it? It tells me what I need to multiply it by. So I have 2 plus v is equal to 22. 11 times 2 is 22. So that's what we mean by cross multiplying complex fractions. Now we're ready to do everything you've been doing so far. Identify your terms, then combine like terms, and isolate your variable. So here we're identifying our terms. Yep, constant, variable term, and a constant. So we did step 2, ready for step 3. Do we need to combine like terms? Yes, we do. We have a 2 and a 22 that need to combine together. How do you combine it? It's the 2 that needs to combine with the 22, but we need to make it a 0 pair on the left-hand side of the equation. That's the only way you can combine. Draw your big fat line and combine. So you have v is equal to 22. Positive 22 and a negative 22 combines to a positive 20. Do we need to isolate our variable from a coefficient? No. Now if you put a 1 here, that's fine, but you don't need to write that 1. It is considered isolate if the only coefficient of your variable is 1, a positive 1. Okay. So that's your answer. V is equal to 20. So we're done with that one and we're ready to check. So I'm looking back at the original problem here. To check, I write 2, there we go, 2 plus 20, because that was our variable that we solved, over 11, and we want to know, does that equal to 2? Order of operations says I need to do anything in parentheses first, when you have a complex fraction like this, you will actually solve whatever's on the numerator and the denominator separately before you divide. It's kind of like invisible parentheses. So do whatever's on the top first, then whatever on the bottom before you divide. So 20 plus 2, or 2 plus 20 is 22 over 11, which 22 divided by 11 is 2. So that's the same thing. They check. I'm going to try one more of these, and that'll be conclude or do now before we start our next lesson. Alright, so we have a complex fraction, more than one term on the numerator or the denominator of that fraction. So when we have the complex fraction, remember you have to cross multiply. So we multiply the denominator to the other side of the equation to get rid of it. N minus 9 is equal to, that was a negative 2 there. 14 times negative 2 would be equal to a, well, a positive times a negative is a negative. And 14 times 2, or if you double 14, it's the same thing, is 28. So we've cross-multiplied. Now we need to identify variable term, constant, constant. You need to do that so that you know whether or not what the next steps you need to take after that. Do I need to combine my like terms, or do I need to isolate a variable? I have to combine my like terms. I have 2 squares. I don't want 2 squares. So you add 9 to both sides of the equation. You add the 9, not the 28, because then that would put the 28 on the same side as the variable. We don't want to do that. So there's our zero pair, and that way our variable can be all by itself. And we're combining the negative 28 and the positive 9. What rules do you use when you combine? SOB. We have a negative 28 and a positive 9. Those are opposite signs, so you have to subtract. 28 take away 9. It's 19. But the bigger sign wins. 28's bigger and it's negative, so your answer is negative. So we're done combining all the like terms. Do you need to isolate your variable? No, we don't need to here because our variable's already isolated. It's already all by itself. So we're done with that step, and then final step is to check our answer. Negative 19 minus 9 over 14. Does that equal to negative 2? So you have to look at your numerator first. Negative 19 minus 9. Oh. Do you recognize that that's a subtraction problem? What do we have to do for the subtraction of integers? Keep, change, change. We have to change that 9 to a negative 9. And now we can combine those two together. Those are the same sign, so we have to add 19 and 9 is 28, and the bigger sign wins, so negative 28. So that's on our numerator. On our denominator we still have the 14. So negative 28 divided by 14 is then negative 2. So that checks. Does equal to negative 2. Alright. If you need more practice with solving two-step equations, see your instructor. Otherwise, continue on to our first lesson in Unit 2.